What is going on, everyone? In this video, we are going to be talking about how you can scale your application to handle hundreds of thousands, if not millions of users using a technique called load balancing. And in this video, we're going to explain what load balancing is. We're going to talk about how load balancing works. And third, we're going to talk about the advantages of using load balancing, followed by finally talking about how you can get started using it. So to explain this, let's use a very practical example of a website that gets extremely popular in a short period of time. So let's just say that we have a machine here, and this is hosting mywebsites.com. And so this website has associated with it a public-facing IP address. Let's just say it's 1.2.3.4 to keep things simple. Now, without having to explain the fundamentals of how the internet works, let's just simplify this for a second and say we have a user over here, and this user wants to make a request to your application, and they're going to do so through a domain name that maps to your public IP address. So you make a request from the user perspective to this application. The application receives it and it'll respond. Now, this works all well and fine, but what happens when you take this user and multiply it by, I don't know, say 100,000, or let's say 1,000 in this example? Well, you're going to have many more requests that are all coming in this direction from many different users. And basically, after a period of time, if all these requests are coming in very quickly, this individual machine is very quickly going to explode and not be able to handle any more traffic. You can think of this individual machine as a pipe in which only so much information can travel through this pipe, and if there's a backlog of too much stuff getting in at once, then all of a sudden the requests stop getting through. So after a while, this machine is obviously going to explode and not be able to handle any more traffic. So how do you solve this problem? And so let's unwind a little bit and go back to the beginning. All right, let's keep that 1,000 there. Now, what's my first instinct here to solve this problem? Well, a very simple solution would just to be add another machine, right? Add another machine, and maybe give this one the IP address 5.6.7.8, right? And so now you say, okay, now instead of this user having to hit this individual machine over here, they can hit this machine too. But we kind of created a problem for ourselves, didn't we? So now we have two different public-facing IP addresses. So how is this user going to know which one to hit? This is kind of an issue, and this is where load balancers come into play. So let's just erase this guy so we can introduce a new component here. I'm going to get yellow for my load balancer. So with a load balancer, it is basically a component that sits between the application servers being these guys, and the requests, so the requests coming from these guys. Now the load balancer will sit in between these two, so let's just put a little block here, and we're going to say LB for short. And now, instead of these IPs being public IPs, previously they were public in the other example, you can make these private IPs, and so they won't be exposed to the public internet. So instead of these being public, you're going to give the load balancer a public IP address. So let's just say it's IP address 6.7.8.9. Now, when the user makes the request to your application, the DNS resolution is going to point to the load balancer's IP address. So say requests are coming in from the user. Let's get some colors here. Request is coming in from the user. It's going to hit this load balancer, and this load balancer is going to know that these two different machines are in the groupings of targets that are available to route traffic to, and it'll decide, hey, I'm going to route traffic to this machine in this case. Or in a different scenario, say a different request comes in from a different user at the same time, it may see that this host is a little bit too busy, and instead it'll direct traffic to this machine. Now these two are two identical machines, so it doesn't matter which host gets the request as long as one of them does. So there's a couple different methods in terms of assigning traffic or routing traffic between the user and the host machines. So the first method is what's called the round robin, or RR for short, so round robin. That's number one. It is by far the most popular. And how this one basically works is, say this is machine number 1 and this is machine 2. Your load balancer will just cycle between these two. So it'll say first request goes to number 1, second one goes to number 2, third one goes to number 1, next one goes to number 2, and it'll just keep on going back and forth between these over and over and over again. This is the most simple one. You usually see this in most applications. Now there's a couple other ones. Well, before that, if you think about this is a pretty naive approach, right? It's just kind of randomly cycling. Surely we can do something a lot more intelligent. So that's where the other two come in, the more popular ones, and they are what's called load-based. Wow, my writing is terrible. I apologize. And so the load balancer is a little bit more intelligent in this case. So if it's seen that this machine here is getting overburdened with traffic, maybe there's too many requests or they're taking too long to handle on this machine, it'll start diverting traffic. So when new request comes in, it'll hit number 2 as opposed to number 1, so that you can kind of alleviate some of the stress that's going on this machine. And so there's two different categorizations of load-based load balancing. The first being least connections. So the load balancer determines which of these machines in the pool have the least amount of connections, and then I'll route traffic to the one that does. So if these two are connections here, then the request would go to this one because 3 is larger than 2. So your request would go here. The other one is resource-based, and so that kind of monitors the machines themselves and says things like, what are the CPU levels in terms of utilization, or what are the memory levels or disk space, things like that, some kind of metric that exists on these machines that report back information to the load balancer. And so the load balancer uses that information to determine who to send traffic to. So let's just erase this for a second here. So those are the two different methods, the round robin or the load based. So let's talk about why this is a good thing. Why is load balancing powerful? Why is this awesome? Well, as you kind of see, you can pretty much scale this up. You can scale horizontally so that you can keep on adding machines down here. So you can just keep on going, adding more and more and more, and then just adding them to the group and just, wiring everything together so that requests actually go to them all. So the first advantage is in terms of scalability. So scalability. These are the pros, the good things about it. The second advantage is in terms of availability. So if this machine suddenly goes down, you have periodic health checks that are occurring between the load balancer and the host machines to make sure that they're in a healthy state and able to receive requests. So for instance, if this one goes down, like we see here, then the load balancer will know to redirect traffic only to healthy hosts. So this effectively gets cut off. So the second key advantage here is availability. Perfect. And so the third advantage is just convenience. If you're trying to shift traffic between different applications, then it's just easy to redirect traffic using just one address as opposed to having to use every individual address that's in this grouping that's hosting this application. So the third is just flexibility or convenience, really. Flexibility in this case. So we kind of discussed here, just to recap exactly what we talked about. So load balancing is the concept where when you get a request, your request is, actually let me just erase this so we start from scratch here. Your request is routed to some of the machines that are in a target group, and this kind of gives you the advantage in the sense that these machines can now be private, so not exposed to the public internet. You get scalability, availability, and flexibility as advantages as well. So this will really help out for those of you that are looking to scale your applications very, very quickly. You can just add n number of machines here so you can handle more and more traffic. So finally, I just want to quickly talk about how you can get started with load balancing. So there's a couple different ways. The absolute easiest way is just to use cloud-based solutions. So cloud-based providers like AWS and Google Cloud Platform and Microsoft Azure have made it very easy. They offer software-based load balancers so that it's just a few mouse clicks away to get this functionality. If you're looking to do this with AWS, you're looking for something called the Elastic Load Balancer. So I would definitely suggest, given the ease of use factor and the ease of setting up, to go with cloud-based load balancers for your sanity's sake. Of course, this solution doesn't work for everyone. There are hardware-based solutions that can work for on-premise configurations. So hopefully you learned a lot about load balancing. If you're interested in scalability and all that, check out this one on the left here on horizontal versus vertical scaling. And as always, if you enjoyed this video, please don't forget to like and subscribe, and I'll see you next time.